Let's get started with the first one. How does this problem differ than what you would see on a test? It has 31. On the test, I would not make it 31 because that's actually a little bit contradictory because before you had the if n's bigger than 30, the sample mean is normally distributed. And now n's bigger than 30, but we're not going to use a z-score. We're going to use a t-score. So on the test, this number wouldn't be a 31. It would be more like a 21 or 11 or a 16. So on the test, that's what will happen, just so you know. But we'll go ahead and deal with it the way it is. How do we know we have to use a t-score in this case? This is going to be a t-score problem. How do I know? S. Notice here it says S. Now again, there seems to be a lot of conversation amongst students about the difference between S and sigma. And for most of you, it's like different brands of ketchup. Ultimately, it's all the same in your opinion. But there's differences between them. S is for the sample, sigma is for the population. So, part A, we have to draw a statistical picture. Where we're going to construct a 95% confidence interval, so this area here is 0.95. Now, if that area on the inside is 0.95, the area on the outside is how much? 0.025. Now, I've told you that I need to use the t-score, so let's go ahead and bring the t-score chart up. Keeping in mind that n is 31, and we have our t-score chart. So, I need to know the degrees of freedom. So, degrees of freedom here is, wait, there's somebody who's identified as our degrees of freedom expert. It is Kelsey. Kelsey is our degrees of freedom expert for this class, and Kelsey degrees of freedom is n-1, Kelsey. Kelsey just went straight to the final answer because that's how she rolls. It is n-1 degrees of freedom for this class. Will always be n-1. In this case, Kelsey, it is 30. So, going down to 30, and again, we're going to be looking at 0.025 in one tail. I generally don't look at two tails. If you just ignore that, you'll be in much better shape. Looking at 0.025 in one tail, coming down to 30. So we're going to be right here. And that is 2.042. Any questions on how we got to 2.042? Degrees of freedom will be n-1. So 31 minus 1 is 30. That puts us on this column, or this row, over the 0.025 column. Okay. So, close that, minimize this. So we're looking at 2.042 as our t-score value. Okay. Now, part B. Part B is to write down the formula. Who remembers the formula? Go ahead.
X bar minus E is less than, call it M, I'm sorry, it's spelled the right thing.
Mu.
Mu is less than X bar plus E. And then E equals T times S over square root of M.
All right. So for those of, for the millions of you watching around the world, I mean for both of you, she said M instead of mu. And I think if you say M, don't you fail the class outright? Anybody remember that conversation? Yeah, okay. X bar minus E is less than mu.
It really does look at U though too, so it kind of makes sense.
Which is less than X bar plus E. And E is equal to T times S over the square root of N. Okay. Now, here, part C is going to be to do the work. So, we're going to have to do 531 minus 2.042 times 33 over the square root of 31. is less than mu, which is less than 531 plus 2.042 times 33 over the square root of 31. Okay. Now, to use the calculator to do the work, we're going to do, we'll pull it over here so we can do this first side first. We're going to do 531 minus 2.042 times 33 divided by the square root of 31. Okay. Enter. So we're going to get 518.9. Okay, remember we're going to go one decimal place further than the decimal in the problem was. Same thing, but switch the minus to a plus. Second enter. And go change the minus to a plus. Okay. So at this point, we'll go ahead and paste that right there. Okay. So we're going to say 518.9. So we'll say 518.9 is less than mu, which is less than 543.1. We agree on this? Part D, how do we interpret? Jacob, go.
If we continue to take samples of size 31, we expect 95% of the sample means to be between 518 and 543.
Perfect. If we continue to take samples of size 31, we expect 95% of the sample means to be between 518.9 and 543.1. We agree on that? The assumptions, anybody remember them from last time?
Part E.
Mm-hmm.
Population is normally distributed and sigma is unknown.
Population is normally distributed and sigma is unknown.
What happened to that paper you were going to give us with all the formulas and assumptions?
Let me pause and get right back to you.
Take a list. Yeah, you might want to take a note.
We're just gonna move on. We're moving on from here right now. That's just what we're gonna do. We're gonna move on. If you want to be able to check this, i.e., Hunter, like have it completely wrong but still get the right answer.
I wasn't here Wednesday when you put over this lesson, so I'm screwed. Anyway.
No, you're fine. No, you're fine. If you want to check this, stat, go to test, come down to T interval. No, I was busting your chops because you got the right answer even though you had the wrong numbers.
Work smart, not harder, right?
No, I agree. I agree. Go down to T interval. We're going to go over to stats. Press enter. Now we're going to type in our mean. Our mean was it 531? Is that right? 531. Our S was 33. Is that right? Our N was 30. N was 31, and we're doing a 95% confidence interval. Yes. Man, that's tight. We can't even get better than that. Yeah, we were right. It's always good to get confirmation on that. or to just write down the right answer whenever you don't know how to do the problem. Just make sure you get the answer right. All right. Now, lastly, Taylor, you know I love you. I mean, in a way that won't get you dinner or leave you very lonely on Valentine's Day. I love you. What if you say it? Several of you violated my number one rule.
Because I couldn't remember the word.
It's okay. It wasn't you, honey. It was more than you.
Oh, I know.
There are a lot of you. I don't need you to self-admit, like this ain't Alcoholics Anonymous. Like, I use the word it. No, you just have to be the person I had a conversation with last about it.
Because I have a broken foot.
And you got a broken foot. It is a pronoun that refers to something. And I think most of y'all go like this. Yeah, it refers to the right answer. Whatever you're thinking, that's what it is when you read that problem. You just fill in what you think it needs to be. Okay? I'll give you partial credit, but you won't get 100. Okay? It is not right. Okay? It is not right. Population is normally distributed and sigma is unknown. Population is normally distributed. Okay? In this case, it's population is normally distributed. All right? But I see it all the time, and ironically,
Is it is, or is it just no it at all?
there's no it, ever. Just go to the dictionary, grab it, and throw it away.
Okay.
Don't ever use that word. Okay?
What's the word?
Depending on the problem, it was, no, sample proportion.
Close enough.
It's close enough. All right.
Could be worse.
Um,
That is a good word.
Now, moving on to number 2. Now, this is the problem that a lot of you will have because here I don't give you all the information. So now you're looking at it going like this. Yeah, we're screwed. Now, here I was actually very nice. Let's just be honest. This was from our 5 o'clock class because they're watching this on the screen. I gave you a hint. You need to find the mean and standard deviation. Use S, not sigma. I will never give you that hint on test day. Because I love you up to the point of getting a gift on Valentine's Day.
So, but in the question on the test, you'll still have population standard deviation, which will basically mean S.
No, population standard deviation is sigma. That's what we're estimating. We're going to estimate sigma using S. Okay? Now, how do you go about finding the mean and standard deviation of all those values?
When you get it right.
You can take Emily's theory, which is just pray on it.
Out the math to find standard deviation, stuff like that.
What's that?
I said I was actually sitting over here writing out all the math and the formula. And doing
Yeah,
it.
I would not actually use the formula there. Stat, edit, and let's type these numbers in. 65, 49, 55, 95, 87, 67, 40, 72. Okay. So stat, calc, one variable statistics. We'll go ahead and take a picture of that. Oh, you. Okay. Now, what are we trying to do? We're trying to construct a confidence interval for the what? We're constructing a 90% confidence interval for population standard deviation, right? So, for the population standard deviation, that requires us to use which chart? The chi-square chart, right? So, we're going to go here, we're going to go here. The area on the inside is 0.90. How much is the area on the outside? 0.1's total. On each little piece, there's 0.05, yes? So, let's go to the chi-square chart. Now, the chi-square chart, we're looking for a 0.01 on the right side, so that takes us to B, right? We're in the B column. 0.05, we're in the D column. That's what happens when you get old. Looking up 0.05, so we're in the D column here. Now, it does ask us for degrees of freedom, which means we have to go back to Kelsey because she's going to tell us degrees of freedom is n minus 1. Now, Kelsey, be careful here because in this case, it is n is what? 8. Now, you can either get that by counting, or you can just look right here. It says n equals 8. So in this case, we're going to go down to 7, come over to 0.05, and we're going to get 14.067. Is that right? So on the right side, we're going to say 14.067. Now on the left side, what are we going to use? We're in column D, jumping to column D here, coming down to 7, you'll get 2.167. Yes. Okay, any questions on that? Now, part B requires us to know the formula. The formula is square root n minus 1 s squared over chi-square right, which is less than sigma, which is less than n minus 1 s squared over chi-square left. Now again, let me just encourage you to understand. This symbol is called chi-squared. Nothing is being squared. And that messes up people every time on the test because they start squaring crap. Nothing is being squared. Okay? It's just a symbol. All right. Yes?
Okay, whenever we round S, what decimal place we round it to?
18.5 is fine.
Are you sure?
Today. Okay. The question was, what did we round S to? I said 18.5 was fine. Clearly there was a moment of she thinks I'm lying.
Well, I wonder why.
I don't know why she would think I was lying, actually. I don't know. I've always been honest,
You
actually.
always change it. Like earlier, you were trying to, you were only rounding it to the second when you said you're supposed to round it to the third. So I don't hear. You should
Yeah, I'm right. All right. Part C. Square root of 18 minus 1. Well, I would probably not be making these mistakes if I wasn't being yelled at by somebody. Completely off my game right now. 8 minus 1. S squared is 18.537.
That was not funny.
18.5 divided by 14.067. Which is less than 8 minus 1 times 18.5 squared over 2.167. Okay. Part D. Am I going to do the math? No. All right.
Hey, dude, in your head.
No, I got a headache. I don't feel like it. All right. Square root. Please don't type in 8 minus 1. Like, you're just going to have to live on the edge a little bit. If you need to, come on here first. All right. 7 times 18.5 squared divided by 14.067. Hey, do keep in mind, and maybe I didn't do a very good job of explaining this, it's the square root of the whole thing. Okay, the square root goes all the way down. It's not just on the top. 13.050, so 13.05. So this side is 13.05, less than sigma, which is less than. This side over here, not quite as easy as the other one where you just change the sign, but we can make this happen. 2.167. Okay. 33.25. 33.25. Okay. Part D. Part D. Interpret. If we continue to take samples of size 8, we expect 90% of the sample proportions. Shit. Excuse me. Call Lakeland. Sample standard deviations to be between 13.05 and 33.2, whatever I wrote. What was that up there? 2.5. Was it 2.5? Yeah. Okay. Part E. Population is normally distributed. A lot of people here will say, and sigma is unknown. Well, of course sigma is unknown. That's why we're looking for it. Right? Like, that's why we're looking for it. Okay?
Just by reading like the problem, how do you know you're supposed to put the formula to use?
All right. That's a great question. The question was, when you look at the problem, how do you know by seeing the problem, how do you know which formula to use when you know which chart to use? For all of these, anytime you do confidence intervals, it'll say construct a confidence interval, but then the most important part will come. It'll say for something. Okay? Now, in this case, it says for the standard deviation. Anytime we're doing a confidence interval, and also hypothesis testing, which is coming up in Chapter 8, anytime we use standard deviation, confidence interval for standard deviation, that's always the chi-square chart.
It says that on the other population.
No, construct a